It for the JavaScript functions is basically just laid out when the functions are used, each one. Step 8.5, step 1, step 2.5. So let's just start with step 1, and we're going to walk through all this, and I've edited the comments as I've gone through and made small bug fixes here and there, but I haven't, so the steps might be out of order. I think what I'll do, instead of putting these inside alphabetical for function names, I think I'll switch it up to just be what order they're used in. I initially started using alphabetically because I was working for a company that just found that as their best practice, and they got so deep into the code that it would take forever to reverse it. And I think it's just like having it in order, and it makes it a little bit more logical in my mind. And you have Control F nowadays, where you just search for a function. So I mean, having an alphabetical order shouldn't be that big of a deal anymore. Anyways, so let's start with function. The step 1. Again, what I'm going to be doing is I'm going to be benchmarking each of these. So I'll be adding in logging to see how long it takes for each of these methods. So let's do a quick code review to see where it can be improved upon, and what we can bring it up a little bit more up to speed. Step 1, it brings in a map just for basic aesthetics. This map is going to be the map that's used to search. Whenever you do search an address, it'll bring a new map with new markers each time. I'm using the Google Maps API, obviously right here. As I set a new map with the default zoom, center right here, and map type control set to true, just so it looks really nice on the screen. And if I have it pulled up, you can see the map controls are at the bottom right here. Zoom in, zoom out, turn on satellite if you want to drag and drop, but I'm not going to bother with that right now. And one of the first things I do is I just grab the input search box right here, and I have autocomplete for Google Maps places right here, just to make the addresses a little bit more cleaner to search and limit the errors of just searching really obnoxious addresses. One thing that I remember having an account for is when a user just searches for a state, like they just search for the state of Alabama, because I have to filter out according to states, because whenever you're searching for an attorney, you can't have an attorney from Michigan come down to Indiana to help out. There's different licenses, and same thing for adjusters and engineers. Um, Now, if you want to search for people in Michigan while you're in Indiana, you can just type in Michigan all for your distance filter, and that's how I kind of work my way around it. Anyways, let's get back to the code review. Now, it lists for key code 13, if you know anything about what key codes, that's the enter key. Basically, it's going to run the plant marker function, and that's going to do a whole mess of things. One important note right here is for my third step, my third milestone, as you would have it, or fourth milestone, I think it actually is I want to be able to save user searches off to another table, and that will include updating the schema, as I mentioned earlier, adding another schema, just call it create table, um, user searches, something really basic. I'll be storing the addresses, the distance filter, and which filter results they use. And that will be used for data analysis. How I'm going to go about um, maintaining that database, because obviously a table can only hold so much information. You don't want to bloat a server down doing that. Maybe I'll save it off to a CSV, and I'll mail it to someone so they have the information. I haven't decided what to do yet for that section, but the basic idea is that when a user does search at this point, that's what I'm going to be calling the save method, and that'll probably involve some interaction with the collective controller over here, um, or the maps controller actually rather, at the index, because as you can see, this is where all my instance variables are used, and if you know anything about Ruby on Rails, instance variables are used to communicate with the views. So let's go back to the JavaScript. This plant markers function is going to take me to step 2. And basically I'm going to geocode the address. Now, geocoding, if you don't know what geocoding is, it's taking a little address, 4511 West 200 South, and creating latitude and longitude coordinates out of it. And Google Maps has an awesome geocoder, although limited, depending on how much you pay. Uh, and it's going to return an object with the status. And if that status is okay, then I'm going to grab the flash container, which is basically something that drops down and lets you know a message. Um, and I'm going to set that to empty. And then I'm going to set the center according to the results geometry location object as it's embedded, and I'll create a new claim marker, and then I'm going to set different variables according to that results object to use later on down the road. And then I'm going to run 4 different methods that I created: setting the zoom, filtering out the state, making claim marker, adding listers. We're going to go through all those, don't worry. And then also have an else, just in case something bad does happen, I have guess address. Let's take a quick look at guess address, which is step 2.5, because it doesn't have to happen. It could go right to 3. Anyways, what I do for this is I call the predicting what the user might be searching for, cleverly named as one of my functions. And I'm just using the predictions API that Google provides. And if that status is not okay, that's when I'm going to log something out in the console. And then I'm also going to grab that flash container that I mentioned earlier that was empty, and I'm going to set it as I couldn't find that address. And then I'll just initiate a new map. If the address is good, I'm going to set the predicted address according to the description of the predictions object. And then I'm going to geocode that maps object. And then I'm going to set the service, autocomplete, get query, predictions, yada, yada, yada. So now that's just in case. I don't think there's going to be anywhere to improve that. That code looks good. It shouldn't be ran too often, to be honest. Let's move on down to step 4, where I set the contents. Now, where's set the contents? Which is exactly why this is going to be changed up to go in order. I'll just do a control find set contents. Oh, that's right. If I would have read the comments on it, this function can be found in partial add adjusters attorney.html.erb, which is right here. This is another thing I want to change. I think I mentioned it earlier. I want to move this over to the collectors.js. The problem is that it requires ERB tags in here. As you can see, I set it right here. This is where the content window data is set at. I don't know if I'll have that ability. I don't know if I have the knowledge or the foresight on how to do that. I certainly don't want to change my file type from JS to a JS HTML ERB. It's just, it could bring in some problems, pollute the document, maybe even slow it down a lot more. Anyways, in here, this is where I'm going to set the names, the numbers, the types, the addresses, everything you can think of for content. And this is just loops through the collectives depending on who you got for, or who you're searching for. And then I run the add marker type. So that's going to send us on back over here. It says add marker is in order. It should be at the top. Add marker. There it is. Great. So depending on the type, I take the choice of the search, the type value, the coordinates, make sure they're not empty, make sure the coordinates are greater than 1. This is just a guard statement to prevent any of the common bugs that I ran into. This is where they went. So perhaps this could be improved, maybe a little bit more safer, incrementally. I don't know, I'll benchmark this method probably. This is all the way to step 8. So there were a couple other functions that I wanted to talk about before I concluded everything, and that was the geocode. That was an important one. Set zoom, as you saw earlier. I don't think there's any way to improve this. Basically just gets the element, sets the zoom level depending on what the distance filter is. Set the contents window. That's obviously a smaller function. I don't think there's any way to improve that. Oh, it's the results info window, not set contents. Make claim marker. I don't think there's any way to prove that. This geocode, we looked at this earlier. This is the one with the 4 methods that kind of activates everything. Main methods I will be looking at improving will be the filter out state helper. So what this does is this takes the user's address, and then it also takes a huge states hash right here. And that's going to compare those two. I have 2 for each, which basically are just 4 loops, and I compare them, and if ever a state matches the word, I'm going to set the user state to the maps. Now this is dangerous. What if you had a street that had a state as part of the address? Now, I mean, I'm assuming Illinois Road doesn't exist in Indiana, but it could. Someone could create it. So therefore, I think this does need to be edited. This could be safer. It could be improved. The algorithms basically just attacks it full head on. I'm assuming once I benchmark this one, it could be improved a lot. The other method that possibly could be improved, that's not heavily dependent on, like a Google Maps API, as you see in the ad marker right here. It's like this is mostly just Google Maps API besides this guard statement right here, which, as I talked about earlier, could be improved. The other one was the Haversine, which is just a brute force way of determining the distance. So, as I mentioned earlier, Google API limits how often you can calculate this between 2 points. It's how many calls you make. Oh, I even have a paid for service and it still limits it. And then I could pay by address, but that could get daunting. Anyways, Haversine just determines it. But taking the latitude, longitude, comparing them, using the math module, and then calculating the distance that way. It's not as nearly as accurate, but it does work. I think I will more than likely benchmark this method too. So that's 3 methods I'll be benchmarking to see what I can do, see if I can change anything, improve it, to filter out the state, the Haversine, and I think it was guess address. Those are the 3 things that I'm going to be looking at. The other one methods are either simple or they're just using the Google Maps API. The geocoder I've tried to break down. This guard on the ad marker I will look at too. And I also want to clean up some of the syntax issues going on, probably because of Internet Explorer, of course. And that kind of collectively gathers up everything I would need to talk about in all this code. While there's more code to look at, it won't be code I'll be touching, and it's more than self-explanatory, kind of like the HTML for my index page on my maps. Like I said, I did most of the stuff. As you can see, I have the initiate maps down there, and then I have the help page right here. I have the method that I talked about earlier that I'm talking about getting put into the other JavaScript, and the HTML for an admin's page, which might be changing depending on the device gem. Anyways, that collects the main topics that I need to talk about inside of this Google Maps Postgres app. I hope you enjoyed, and I look forward to refactoring, adding, and improving the app.